Yes, welcome back again to Achievers Meeting Point. Today we are going on our second video. That's looking at the algebraic approach. Last time I looked at the graphical approach. Now we're going to look at the mathematical one, that's the algebraic approach. Now under algebraic method, it's better considered to the graphical method. And in this case, our break-even point can be computed in terms of units or money value, as we had seen in recent terms, but you had seen this in the other video. It was difficult. You could just draw a graph under the accountant's model and the economist model. But now under algebraic method, you're going to be able to calculate the break-even point in terms of units or in terms of money value. So I want us to get a look at those methods and we see. So we all understand that at break-even point, that's where marginal cost equals marginal revenue. And at that point, we are not making any profit. That means our profit equals to zero. That means whatever we're earning, we're spending it on the cost. That's why you're saying marginal cost equals marginal revenue. So from that belief, that means our net profit at that case is zero. So under to get net profit is total revenue minus total cost. So looking at the net profit, understand it's a zero. So I hope you understood that it is a zero, whereby you're getting the total revenues, you subtract the total costs, and at the break-even point, whatever you're producing, you're selling it, and whatever you actually is covering only the costs. So you're getting a net profit as zero. That means your total net profit is a zero. But remember, you have to remember in mind that to get your total revenue is supposed to be price times quantity. That's why we have the case of a P. P representing price and Q representing quantity. That's total revenue equals to price times quantity. Whereas to get total costs, we get the fixed costs, which I'm calling in this time A. So the A is representing fixed costs plus the variable cost times quantity, and the variable costs are being represented by B. So to get total cost, you get a fixed cost from the plus the variable costs. So in this case, fixed costs are being represented by A and the variable costs are being represented by B. Then if you look at our net profit, now we are substituting in the two items. So now substituting the two items, I will have net profit equals total revenue. And in this case, the total revenue now is price times quantity. That's why I'm having a PQ. Then minus fixed costs, minus the total cost, and the total cost is being represented by fixed cost, which is A, plus variable cost times quantity, which is BQ, and then it will give me a zero. So I'm substituting now into the formula of net profit equals total revenue minus total costs. Now in that case, that means I'll have PQ, that's the price times quantity, minus A minus a BQ. I'm getting it from a case whereby so after understanding the net profit, substituting the PQ into and the total cost functions, then you make a function now. I'm getting out the PQ and the A and B. So that means I'll have a PQ minus A. A is coming out, becomes a negative A, minus a BQ. Since BQ is also coming out, it becomes a negative BQ. And the total of them will equal to a zero. From up, our net profit being equal to a zero. Hope we still remember. So it's still the same thing. Then I will solve the equation now algebraically. So I'll have PQ minus a BQ. Now remember, I'm looking for quantity, so I have to make quantity the subject of the formula. So I'll have PQ minus a BQ equaling to A. So I collect like terms whereby I have PQ and BQ, and I put Q outside to get Q outside, and I'll have P minus a B. That's how I'm collecting like terms. Then I will equate to A. So after equating, I can make Q as the subject of my formula. So that means to get the quantity at the break-even point is going to be quantity equals to A being the fixed costs, out of P being the price, and B being the variable cost. So you have to master now this for the whole of this life. Now you have to understand that to get your quantity at the break-even point, you have that formula. Master it, and you'll master it forever. So I've made for us the brief formulas that we are going to have in order to get the algebraic method, and these formulas that you're going to use forever throughout this course unit. So the first one is the contribution. Contribution is what you remain with after selling your product. Now contribution will always be equal to the selling price minus the variable cost. That is for a single unit. Contribution for a single unit. But in case I've give you total product, total units, and they'll give you the total sales. That means to get their contribution is going to be the total sales minus the total variable cost. Then you have the quantity at the break-even point. You had already looked at it. That is fixed cost out of the sales minus the variable cost. But you had already seen, I've already told that sales minus variable cost is our contribution. Then contribution to sales ratio, because you're going to need a contribution to sales ratio. How much is this contribution in relevance to the sales? And it will be summed up into contribution out of the sales. We have already seen how great the contribution and the sales, in case it is for a single unit, to be just the selling price. Then in case for the total units, they'll give you different units, you'll get the total contribution divided by the total sales times 100%. Then the sales, the sales now looking at the value, the amount. As I told you earlier, that the algebraic approach will help us to get the quantity and the monetary value at the break-even point. So now this is the sales at break-even point. How much money are you supposed to make? How much sales are you supposed to make in order to break even? So it will be fixed cost out of the contribution to sales ratio. We have so far looked at making contribution to sales ratio. So now let's have an example of it and we'll try out and see how it works out. So our question goes, you can first read it. So the question goes, Gloria Company manufactures and sells a single product called rice balls. The company has a running budget of 164,800,000 on producing 200 units of rice balls. This figure contains a fixed cost of 160 millions. Required, calculate the number of units to break even, 2, the contribution to sales ratio, and 3, the sales at break even point. So that's our question now. That's our tryout question. We want us to try this question and we see how we apply the algebraic method in cost volume profit analysis. So, a note to remember is that the NB, the company sells the product at 40,000. So from there, we want us to look now at how the question is solved. Having the selling price, we have the total fixed costs, we have the units produced. So we want us to see to find the quantity at the break-even point, the contribution sales ratio, and the sales figure that can be at break-even point. So our first question requires us to find the quantity at break-even point. I know that the quantity at break-even point is supposed to be got from fixed cost divided by contribution. So we already have the fixed cost, that is 160 millions from our question. Then contribution is supposed to be got from selling price minus the variable cost. So that means I have to first find the contribution. So my selling price is 40 millions minus the variable cost. But if you can review again the equation, we don't have the variable cost. So that means it puts me to a task to look for the variable cost. So I included this one in order to make us understand how we can look for the variable cost in the case it has not been given to us. That means now, since I have the total cost, I'll be able to find the variable cost. So I know that total cost equals to fixed cost plus variable cost times the quantity. So knowing that total cost equals fixed cost plus variable cost times quantity, and I already have the total cost, I already have the fixed cost, and I already have the quantity that is produced budgeted before. That means I'm able to get my variable cost. So from the total cost of 164,800,000 and my fixed cost of 160 millions, I don't have the variable cost, but I know the quantity is 200. I can make an equation. So from making an equation, I'll solve the equation. I'll bring 160 millions this side. That means I'll subtract 160 for 800,000 minus 160 millions equaling to 200 VC. Automatically, the 4.8, that means the total variable cost. So the difference, which is 4.8, is the total variable cost. So I'll subtract 4.8 and the remaining is 4.8, which will equal to 200 VC. When I divide by, I'll get the variable cost per unit. So that means I'm able now to achieve my variable cost per unit. That's a startup point for me. So now let's look at how we are going to now. That means you are able to get the contribution. So let's try to get the contribution now and with. So I've already got my variable cost. That means I'll be able to subsume by contribution. So from contribution equals selling price minus variable cost. And I know the selling price is 40,000. I've found the variable cost of 24,000. That means when I substitute in, I'll be able to get the contribution of 16,000. Good. Then I can proceed on now to get the break-even point quantity. And I know the break-even point quantity is got from fixed cost divided by the contribution. So I know the fixed cost is 160 millions and the contribution is 16,000. So when I divide, I'll get the 10,000 units. That means for Gloria company to break even, it must have the 10,000 units produced using that budget. So at that point, at 10,000 units, it will be making no losses and making no profits. So Gloria company to break even with making their rice balls, they must produce 10,000 rice balls in a month in order to break even. Good. Let's continue now to proceed and look at the contribution sales ratio. So my next part was contribution sales ratio, and that's what I'm going on now. I know that contribution sales ratio is equal to contribution divided by the sales, but I told you in case the single unit is going to be one is single unit contribution divided by the selling price. So in this case, I'm going to use the single unit. So I'll get the contribution of a single unit divided by the selling price times 100%. And I already calculated my contribution, which is 16,000. So I'll just bring the 16,000 divided by the selling price, which is a 40,000. That case, that's the sales for one unit. So I'll get 16,000 divided by 40,000 times 100%, giving me 40%. Meaning this product, out of on the sales we make, it only contributes to 40% of the variable costs. So let's continue. And the last part was requesting us look at the sales at break-even point. So my sales at break-even point, I know that from the formulas that we looked at in the beginning, that sales at break-even point equals to fixed costs divided by the contribution to sales ratio. And good, everything, I have it already. I just substitute into what it needs. So I'll get the fixed cost, which is 160 million, which I already have, divided by the contribution to sales ratio, which I've just computed, which is 40%. So when you divide 160 million divided by 40%, it gives you approximately to 400,000 shillings. So that means in order for me to break even, in order for Gloria company to break even, it must make a sales figure of 100 millions so that it can break even in its sales. So good. So that's under a single unit cost volume profit analysis. Let's meet in the next video where we're looking at the multi-product cost volume profit analysis. Endeavor to subscribe, like, and comment in case of anything.